Military power no longer begins on the battlefield. It begins in orbit. Modern warfare depends on uninterrupted data flow across space, air, sea, and land. Satellites form the nervous system of this structure. Early military satellites focused on simple relay functions. Voice transmission, navigation signals, and basic reconnaissance defined their role. These systems were predictable, slow to adapt, and vulnerable to interference. The next generation of military satellite communication is fundamentally different. It is designed for contested space environments. Survival, resilience, and speed are the primary objectives. Modern military satellites operate across multiple orbits. Low Earth orbit, medium Earth orbit, and geostationary orbit each serve distinct roles. Low Earth orbit constellations provide low latency and rapid refresh rates. Geostationary platforms deliver persistent coverage and command authority. Future systems integrate both layers into a unified architecture. Data routes dynamically based on threat conditions, signal quality, and mission priority. This removes single points of failure. Signal security is central to this evolution. Advanced encryption is combined with frequency hopping, beam shaping, and directional transmission. These techniques reduce detectability and limit interception opportunities. Laser-based satellite communication is emerging as a critical capability. Optical links offer higher bandwidth and lower probability of interception. Unlike radio frequency signals, laser communication is difficult to jam due to its narrow beam width. Artificial intelligence now manages traffic routing and threat response. Satellites can detect jamming attempts in real time. They autonomously reroute signals or change transmission parameters without human intervention. Resilience also depends on scale. Large satellite constellations dilute the impact of individual losses. Destroying one node does not collapse the network. This shifts space conflict from decisive strikes to prolonged attrition. Military satellites are no longer passive assets. They are maneuverable platforms. Modern designs include propulsion systems for orbital adjustment. This allows evasion of threats and repositioning based on operational needs. Strategic power projection relies on space-enabled awareness. Real-time communication links connect sensors, shooters, and commanders across continents. This compresses decision cycles and enables synchronized operations at global scale. Hypersonic weapons, unmanned systems, and cyber operations all depend on satellite communication. Without secure space links, these capabilities lose effectiveness. Future war will involve deliberate attempts to blind and isolate adversaries. Jamming, spoofing, cyber intrusion, and kinetic anti-satellite weapons are all part of this domain. Next-generation systems are designed with graceful degradation rather than total failure. Command and control architecture is shifting from centralized hubs to distributed nodes. Authority can be delegated and reassembled dynamically. This increases survivability under attack. Space is now a contested operational domain alongside land, sea, air, and cyber. Military satellite communication is the foundation that connects all others. The quiet signals moving between orbiting platforms determine who sees first, who decides first, and who acts first. These whispers from space shape outcomes long before forces engage directly.